In this video, I will explain you image formation by spherical mirror, especially concave mirror. Okay. Now we will take different positions. We know that R is the center of the curvature, or this can be written as C, and F is the focal point and P is the pole. So first, in front of a concave mirror, so this is a concave mirror. In front of the concave mirror, I am keeping my object at a distance which is larger than C. So beyond C, I am keeping my object. So for image formation, I need minimum 2 rays. So first ray which I am going to consider is the ray parallel to principal axis. So this is parallel to principal axis. So on reflection, that would go through focal point. Next ray which I am going to consider is the ray which is going direct to pole, and after reflection that would go in this way, having an intersection at this point, and that will create the image here. So this is the head. From head, these two rays are coming. So this point of intersection would also be head. And next ray for the tail, I am only going to consider one ray which is passing through the pole. So after reflection, that would go in the same direction. So here would be the pole. Okay, so from pole, this is the ray that creates a tail, and from head, 2 rays, and that creates the head, and I have an inverted image here. And you can see the size in this picture. This is a size diminished. Now, this is the point beyond C, right? Now, I'm going to consider one more point which is at a very infinite distance away from the mirror. So at an infinite distance, you know that we have only rays coming in parallel to the mirror, and these rays, if they are parallel to each other, on reflecting on the surface of mirror, that would directly go and intersect at focus point. So at first point, I am going to consider at infinity. From infinity, lights would be parallel to each other, and these parallel incident rays after reflection, that would go through focal point. This we already have learned, that 2 parallel lines after reflection, that would go through the focal point and creating an image here. So the image here is point image, and that would be inverted and real image. Okay, orientation means whether it is erect. Erect means head top and tail bottom, and inverted means head down. Okay, so this is head up and this is head down. This is erect and this one is inverted. Okay, next thing is the one which I have told you before, between infinity and C. So this is infinity, this point is between infinity and C. When I keep here, the size is smaller, and that is the orientation is inverted. So between infinity and C, my image is between C and F, right? C and F, then that is a diminished, size is smaller, and inverter, head down, and real image. Real image means the image is formed after the actual intersection of rays. See here, these 2 red lines, these lines after reflection, that would go in this way, and they actually intersect at point, this is point M. At point M, they are actually intersecting, so the image formed is real image. Next thing is between, at C. So at C, what will happen? Which are the rays I can consider? So this is C. This one would be C. Okay, first ray I am going to consider is the one which is going parallel to this, parallel to principal axis, that would go through focal point. And the next ray I am going to consider is the one which is going to pole, and after reflection, that would go in this way and creating an image here. See here, object is having object is erect, anyway having head top and tail bottom, but our image is having head down. So it is an inverted image, and the position of the image is at C itself. At C was our object, and at C itself is our location of image at C itself. And size, these two sizes are equal, so the same size. And is it a real image? Yes, because they formed after actual intersection of reflected rays. Okay, now next thing is between C and F. So it's the same thing. So if I'm keeping my object here, I will have my image here. Now if I'm keeping my image here, object here, I will have my image here. So anyway, I'll redraw it. This is my C and this is my F. In between C and F, one line parallel to F and going through F, parallel to principal axis and going through F, another line, another rep going towards pole, and after reflection that would go in this direction and creating a image here. So this is object, size of image is higher compared to object, so this is magnified image here, and the position of the image is between infinity and C. So between C and infinity. Next thing is size. Okay, here see head top, here head bottom, so it is an inverted image. And is it a real image? Yes, because this image is formed through actual intersection of rays, reflected rays here, right? So this is a real image. Now at F thing is, at focal point, if I am keeping my object, what will happen? The rays after going in this way, that will pass through focus itself. So any ray if you are considering, okay, so these rays will never form an image. Or at F I can say that location of the image would be infinity, and this is undefined. We see these two parallel rays, we don't know whether they intersect or not. If at all if they intersect at larger distance, you can just draw it. So these two are parallel rays. Okay, so anyway at infinity, at focus, image is at infinity, and as the image, we don't know about image, we have to say that orientation is undefined and even nature is undefined, because we know that parallel lines do never intersect. Okay, so the size would be, if at all if they are intersecting at one point, that would be a point very large away from it, so it is a very large image. Next thing is between F and P. It's very important between F and P. So let's say this is our mirror and this is my C. C would be here. Okay, so my F would be here. So in between F and P, it would be this case. P, so first ray I am going to consider is the one which is going towards P. After reflection, that would go in this direction, making the same angle theta with principal axis. Now next thing is the ray I am going to consider which is passing through F. So what will happen? That after reflection, that would go parallel to principal axis. So all the ray passing through focus, so actually a ray comes and that meets the object here, and now from object the ray is coming in this direction, and after reflection that is going in this direction. So we know that these two rays can never intersect. See, now the distance is shorter, larger, larger, larger. So as distance goes, this will become larger and larger and larger. They will never intersect. But if I am projecting to this side, see, it would go in this direction and this would go to this direction, and I could say that this would be the image. So they are not actually intersecting. See, in all the previous cases they were actually intersecting, but here they are not actually intersecting. But when we are seeing at this place from in front of the mirror, it seems to be intersecting at this point. Our eye is catching these two rays, this ray and this ray. So this ray is saying that the object is somewhere in this line, and this ray is saying that the object is somewhere in this line. So they do intersect at this point, but this is not an actual intersection, it's an imaginary intersection. So they will form an imaginary image here, but thing is, it is, see, heads up and heads up. So it is erect image, see, erect object, erect image. Okay, so between F and P, orientation is erect. Okay, head top, tail bottom. Next thing is, what is the nature? This is a virtual, they are not actually intersecting. Now size is, as compared to this, it is larger. And where is the location of the image? Other side of the mirror. So this is the actual side of the mirror. On the other side, we have the image. Okay, so this table is very, very important. Okay, thank you.